Welcome to Center of Math's Images in Math. Today we're going to talk a little bit about some fundamental polygons. So essentially by taking a square and by identifying some of the edges, we can create some different figures. So take a square, if we just identify two sides together, so we just put two sides together, we just have a loop. Now if we identify, so instead of, this point goes to this point, we go from opposite point to opposite point, and then this point to this point. So we identify these edges, but they're kind of reverse of each other. That'll give us a Mobius strip. So essentially what we're doing here, if we have a long sheet, we take one side, we twist it, and connect it to the other side, and that gives us a Mobius strip. Mobius strip is kind of neat. It can't be orientated. Yeah, we can't really select, this is the outside, this is the inside side. It also, if you cut it down the middle, you'd notice that in fact we get one loop instead of two loops you might expect from like a regular circle. We get, in fact, one connected loop that comes out of cutting down the center. So yeah, an image right here of a Mobius strip. So now we can identify some other sides. So the two A sides will be identified together. The two B sides will be identified together. The arrows tell us what the orientation of the sides will be identified with. So the end of the arrows will go together. So these two ends go together, these two ends go together. And here what we'll have is something topologically that looks like a sphere. So right here we can see a sphere. And a sphere is a pretty well-known figure. Just, if you have a ball, the surface on a ball, that gives us a sphere. And this can be orientated. So here, now, again, the A sides go together, the B sides go together. Here both sides are kind of twisted together. So this figure here will give us the real projective plane, which we can see a figure here. And yeah, this is a figure we can't actually have in 3 dimensions without intersecting itself. But yeah, so that's one more figure. So this figure here, it'll give us something called a Klein ball, which we can see here. This also, like the real projective plane, cannot actually be embedded in 3-dimensional space without intersecting itself. But there are common images of it in 3D planes, just will be intersecting itself. So here we essentially take a tube, and instead of bringing it together like a torus, we kind of take it and twist it inside so that we have the kind of opposite ends lining up, as opposed to the same ends lining up. So yeah, the tube will kind of come back to itself kind of from the inside of the tube, like you can see there. Kind of like a Mobius strip, we can't orientate a Klein ball. So yeah, we can't orientate it. It can be constructed from a Mobius strip by gluing opposite ends together. And it can be embedded in 4 dimensions without it intersecting itself. So lastly, a bit of a simpler image is a torus. So here we bring two sides together, then we just connect those two sides, and that gives us like a donut shape. Torus is relatively a simpler figure. You can see it right here. Yeah, it's essentially a donut. It's a common shape. It can be embedded in 3 dimensions, and we can see its image. And yeah, and that's a couple different shapes we can make from pairing up edges of a square. Thanks for watching. Please check out the rest of our videos in the Images of Math series. Thanks for watching.